Hey, fourth graders! Today's lesson is going to be on reviewing fractions and then focusing specifically on finding equivalent fractions. So before we get started, I would like to review some of the vocabulary words we've learned in Unit 3 so far. And one of the things we've really talked about is the fact that every fraction is part of one whole unit. So as you can see in my example here, I have an apple, a cake, and a strawberry. And you can see that in all three of these pictures, we just have a part of each of one of those, or as we would say, we have a fraction of each of these. You can see that I have 1/2 of the apple shaded green, 1/2 of the cake is gone, and 1/2 of the strawberry is also gone. And this week we've learned that when we read fractions, we know that these numbers over here are very important in helping us understand the fraction. We know that the denominator, the number on the bottom, tells us how many parts the whole is cut into, and the numerator tells us how many of those parts we're referring to. So in this case, you can see that the apple is cut into 2 parts and one of those is green. You can see the cake is cut into 2 parts and one of those is gone. And also, just like the cake, the strawberry is cut into 2 parts and one of those is gone also. The denominator is very important. Like I said, it talks about how many parts of the whole there are. In this example, you can see the denominator is 4 because there are 4 birds in this whole group. And the D in denominator is a nice little reminder to think of the word down or downstairs. The denominator gives the number of equal pieces or equal parts in the whole. The numerator, the number on the top, refers to how many of those parts that we are talking about. So in the example of the bird, you can see that the numerator is 3 because 3 of the 4 birds are ducks. And the numerator, of course, is the number of parts or pieces that we're talking about. And this week we cut out fraction circles so we could actually see and manipulate and hold and line up different fractions. And we made those from our journal this week. And we learned that we can actually look at this as a way to determine what an equivalent fraction is. We learned that 1/2 is the same as 2/4, and 1/2 is the same as 3/6. And 3/6 is the same as 4/8. And the word we use when we discuss that is equivalent fractions. Equivalent fractions are different fractions that actually name the same value. So in this example, you can see that 3/6 and 5/10, even though they may be cut up differently, are referring to the same thing. They are equivalent, and they're also equivalent to 1/2. After we worked with our fraction circles, then we got out our number lines, and we also saw that this was a different way that we could compare fractions. We can see from this that 1/2 is equivalent to 2/4 and is equivalent to 3/6 and is equivalent to 4/8 and so on. And we used our rulers and we lined up and we could compare all kinds of fractions this week to determine if they were equivalent. But then as we got going, we decided that there may not always be a time that we have our fraction circles in front of us or have our number lines with us. So we decided there has to be a better way to figure out if if a fraction is equivalent to another one. And that's when we learn the multiplication rule. So in your homework for these virtual days, we're going to be practicing and reviewing what we learned about equivalent fractions. And one of the things we learned was that we can find an equivalent fraction using multiplication as long as we multiply both the numerator and denominator by the same number. So I'm going to walk through this worksheet with you. This will be some independent practice for you, and it'll be somewhat together work, our whole group work, as I walk through an example of each so you can kind of refresh your memory and remember what we did with equivalent fractions and multiplication this week. So number 1 here, it says fill in the models and missing numbers to create equivalent fractions. So my example over here shows that 3 out of the 4 pieces of the circle, or 3/4, is shaded in. We know that we can represent 3/4 using 12ths, even though it may be cut up a little bit differently. Now, rather than getting out our fraction circles or getting out our fraction lines, we know that we can find this by using multiplication. So what we need to think is, how do I get from 4 to 12 using multiplication? Well, I know that I can do 4 times 3 to get 12. And if I do times 3 on the denominator, I need to do the same to the numerator. And if 4 times 3 is 12, 3 times 3 is 9. And I would simply shade in 9 of those pieces. And I'm going to have you take a minute and do the same thing over here. Be thinking about how do you get from 5 to 10 using multiplication, and whatever you do, whatever you multiply that 5 by, you need to do the same with the 3, the numerator. So to get you started, I know that I can do 5 times 2 to equal 10. And if I did that for the denominator, I need to do the same for the numerator. So I'm going to have you fill that one out on your own. And you'll be able to see once you do that, oh yeah, these guys are equivalent. Down here it says fill in the missing value to make both fractions equivalent. So I have 1/2, and it's asking me how many 12ths are equal to 1/2. So I'm thinking about the multiplication rule. I have to think, okay, how do I get from 2 to 12 using multiplication? Well, I know I can do 2 times 6 equals 12. And if I do times 6 for the denominator, I need to do times 6 for the numerator. And 1 times 6 is 6. And if I look over here, I think, okay, this time the denominator is missing, but it's all right because I know that whatever I do to the numerator, I'm going to do to the denominator too. And I think, how do I get from 3 to 6 using multiplication? Well, times 2. And if I do times 2 on the numerator, I need to do times 2 for the denominator. And 7 times 2, of course, is 14. And I'll have you complete 5 and 6 on your own as independent work. All right, numbers 7 and 8 have fractions already listed, and it's asking you on this one, which fraction is equivalent to 2/5? So I have to think, all right, I need to check 2/5 with each of these thinking multiplication and see if they're what we call a match. So in 2/5 and 6/9, I think, okay, I can do 2 times 3 to get 6, that works, but 5 times 3, that's not 9. So I know it cannot be A. Then I think, okay, let's compare it to 4/10. 2 times 2 is 4. And hey, what do you know? 5 times 2 is 10. This one is a match. It's equivalent. Down here, I think, okay, 2, there's nothing I can do to get from 2 to 5 using multiplication, so I know it cannot be C. And same with D. There's nothing I can do to get from 2 to 9 using multiplication, so it cannot be D either. And I'll have you fill out number 8 on your own. All right, number 9, which fraction is equivalent to 2/12? So I have 1/6, 4/6, 4/8, and 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I have 3/9. All right, so I look at these and I think about the multiplication rule we just talked about for number 7. Is there a way I can get from 1 to 2 using multiplication? Sure, 1 times 2 is 2. And if I do that for the denominator, 6 times 2, yep, that's 12. This one is equivalent. So when you do number 10, I would recommend doing that exact same thing that we did. First, write the fractions beside each circle, and then tell me if it's equivalent. Check multiplication. Check if it works out with both the numerator and the denominator. Number 11, Elena has jogged 9 laps. She wants to jog a total of 12 laps. The shaded region of which figure models the number of laps Elena has jogged out of the total she wants to jog. All right, so it looks like she wants to jog 9/12. She's already jogged 9 and she wants to jog 12. Which of these is equivalent to 9/12? This one is 3/4. 1, 2, 3, 4, 5, 6, 7, 8, 9. Looks like we have 4/9 here, 2/5 here, and 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5. All right, looks like I have 6/10 here. All right, think about the multiplication rule and circle which one of these is equivalent to 9/12. Then I'm going to have you flip it over on the back. And on this back side, it says fill in the first model to represent the fraction given. Then write an equivalent fraction for each fraction and prove it with a model. All right, so I have 1/3. I'm going to do 1/3 and shade this in. And then I'm going to cut these into 1/6. And I'm going to put a 6 here. And I know to do 6, I have to do times 2 and times 2. So if I do 3 times 2 to get 6 here, I need to do 1 times 2 to get 2 there. And I'm going to shade in 2. You can see that these are equivalent. 2/5. I would recommend doing times 2 again. Keep your circles easy. Cut each of these in half. And if this is 2/5, what would that look like over here? How many tenths would that be? Now, if you would like to cut it a different way, you can. I'm going to recommend doing it times 2 and cutting it in half just because I find that to be a little bit easier. And then I have 4 times 2 and 6 times 2 will give you how many 12ths? Down here it says, are the fractions below equivalent? Write equal or not equal for each one. All right, so I think, okay, on this first example, is 2/8 equal to 6/12? Well, I think to get from 2 to 6 using multiplication, I have to do times 3. But 8 times 3, not 12. 8 times 3 is 24. So this one, not equivalent. And then down here, for this section, fill in the missing value to make both fractions equivalent. So I think, how do I get from 6 to 36 using multiplication? Well, 6 times 6 is 36, and if I do that for the bottom, I have to do that for the numerator, and that would be 6/36. So I'm going to let you guys finish the rest of this as independent work. Now remember, if you get stuck and you have questions, always go back to my Unit 3 EDM resources link on your Clever page. And since this is from lesson 3.4, feel free to jump on 3.4 and remind yourself of what we did with equivalent fractions. You can also go back and review lesson 3.1, 3.2, 3.3. There's all kinds of really great things on fractions that you can use on your Clever page. Really handy if you get stuck. And then when you're finished with it, just tuck it back in your bag, tuck it back in your folder, and you can bring this back to school with you when we return on Monday. Also, one more thing that you can do just for fun, doesn't have to do with fractions, but it does have to do with multiplication. And when we've learned that there are all kinds of things that we can do with multiplication. Shoot, we've even been using multiplication with our fractions. So we're going to review our multiplication facts. We're going to work on those 9s. And I threw in this game that you are welcome to play with someone in your family. It's called Thanksgiving Catch a Turkey times 9. All right, it says players take turns to roll 2 dice and add those numbers together. Then, with your added numbers, multiply them by 9 and place a counter over the number on the board. So for example, if I were to roll a 3 and a 5, I would add those together to get 8. And 8 times 9 is 72. So I would cover up a 72. Play continues until one of the turkeys is surrounded with a counter on each of the spaces around it. The player who places the last marker to catch the turkey is the winner. So it's called catch a turkey. So every time you surround a turkey and you're the last one to shut the gates, to cover it up with a counter, that turkey is yours. And once you have them all done, whoever has the most turkeys is the winner. All right. Thank you so much for tuning in, 4th grade. I hope you guys have a wonderful Thanksgiving. Enjoy the holiday with your family, and I really look forward to seeing you all next week. Bye, guys.